Welcome, students, to the test number 3 corrections. Let's go ahead and take a look at the problems that you guys missed. Number 1 was a problem that some of you missed. And so let's quickly take a look at, okay, arc cosine of 1. Of course, that means that we want to find the angle x. And when you take cosine of it, you get 1. Well, first of all, anytime you're trying to take cosine of an angle that gives you out 1, you understand you're looking for a quadrant angle. So if you type in cosine of 0, that does not work. Or it does work, excuse me. If you type in the cosine of 90, that doesn't work. Cosine of 180 gives you -1, it doesn't work. Cosine of 270 does not work. And so the answer is 0. There is no other answer that works. And I'm not being mean, but I really can't make it any easier than that. The answer is 0, okay? Whenever you take the cosine of 0, you get 1. I think the person that missed this, and I bet one or two of you, I think one of you put 180 for an answer, and of course if you type that in, the cosine of 180 is -1, okay, so that would not be correct. Alright, moving on to numbers 4 through 6. Number 5, nobody missed number 4, and nobody missed number 6, so moving on to number 5. Now I warned you guys about doing this. I warned you about seeing arc cosine, then cosine, and just saying, oh, here's my answer, and putting that down, okay? That doesn't always work. Because of domain issues with what your angle is allowed to be when you're dealing with arcs. Okay, so always be careful. Okay, and some of you did that, and that's why you missed it. Okay. All right. First of all, we have arc cosine of, and then we're going to find the cosine of -5 pi. Now, -5 pi, of course, is you go around once, that's 2 pi. Go around again, that's 4 pi, and then go to here. So really it's the same thing as 180 degrees, okay? So you're welcome to do 360, you see, times 2 plus 180. You're welcome to take the cosine of 900 degrees. Actually it's -5 pi, I apologize. So it should be go down, there's once, there's twice, and then again, okay? But either way, you're welcome to take the cosine of -900, or you're welcome to take the cosine of -180. Either way, you'll get the exact same answer. Okay, I'm going to type that in real quick. Cosine of -900 is -1, and the cosine of -180 is -1. Okay, so either way, whether you use 5 pi in radians, or not -900 degrees, or -180 degrees, either way, you're going to get -1. Okay, so first of all, when you take the cosine of -5 pi, you're going to get -1. So now we're left with this. Okay? And now we're looking for the angle that when you take cosine of the angle, you get -1. Well, remember, cosine is restricted to this quadrant here, to this quadrant over here. Okay, and we're looking for a quadrant angle, either 0 or 90 or 180. Those are the only answers we can have, okay? And obviously it's going to be 180 because the cosine of 0 is 1, the cosine of 90 is 0, and the cosine of 180 is -1. So the answer is 180. Remember, guys, whenever you're taking the arc cosine, you immediately are limiting your theta, or your angle, to be greater than or equal to 0 and less than or equal to 180. Okay, please remember that, guys, very important. Or you could say 0 and pi if you wanted radians. Okay, all right, I hope that made sense. Moving on to number 7, we're going to write this as an algebra expression. Now Michael, you did really well in the test. I think in this problem here, if you'll look carefully in your denominator, you had a -2 minus x squared, which should have been a positive. So I think I just took 1 point off, I'm pretty sure, for that. A lot of you missed this for other reasons, so please take some really good notes here, okay? Okay, students, so here we go. First of all, notice we have in the inside here arcsecant of x minus 1. So what that means is we're looking for an angle that when you take the sine of that angle, you get x minus 1. Okay, so really I can put x minus 1 over 1. So I'm going to go ahead and draw my triangle over here. And I'm going to put theta right here, and we have sine of theta is opposite over hypotenuse. Now, if you quickly use Pythagorean's theorem, you're going to have 1 squared. Well, we'll have your leg squared plus your other leg squared equals your hypotenuse squared, okay, which is 1. Sorry about that. 1 squared. So you'd really have L squared plus x squared minus 2x plus 1 equals 1 squared is 1. And then bring all this over. You have L squared equals negative x squared, positive 2x, and then of course the 1's will cancel out. Take the square root of both sides, and you have the square root of negative x squared plus 2x, okay? So there we go. Now, remember, anytime you see arc sine or arc cosine or arc tangent, it's really a way to rewrite an angle. You're rewriting an angle, okay? So arc sine represents an angle. We don't know what that angle is, but we wrote a triangular representation of that angle. So now that we have that triangle all set up, now we can go on to the last step, which is take the secant of theta. And secant, of course, is the reciprocal of cosine, which would be hypotenuse over adjacent. So hypotenuse would be 1. Over adjacent would be this right here. Now, if you multiply the top and the bottom by the square root of negative x squared plus 2x, you're going to get negative x squared plus 2x all over negative x squared plus 2x. Okay? And that is the answer right there. All right? I hope this is making sense. If you have any questions, don't hesitate to call or email. Let's continue on. Okay. Find the other 4 trig values by using identities only. Now, remember, first of all, let's see what quadrant we're dealing with. Tangent of a given angle is positive. So that would be here or here. And then secant, which is the reciprocal of cosine, is also positive. So that would not be this angle here. So we're dealing with this quadrant right here. So we're going to go ahead and put x here. Now we know we're dealing with quadrant number 1. Okay, so that's important to know. So everything will be positive. Now, we need to find the sine of x, the cosine of x. We already know the tangent. We need to find the cosecant of x. We already know the secant, and we need to find the cotangent of x. Okay, so here we go. Well, first of all, cotangent should be pretty easy. Cotangent is the reciprocal of tangent. So if tangent of x is 2/3, then the cotangent of x would be 3/2. There we go. And same thing with cosine here. If secant of x is square root of 13 over 3, then if I reciprocate that and flip it over, I'll get the cosine. So I get 3 over square root of 13. If you rationalize the top and the bottom, you will get 3 square root of 13 over 13. You cannot reduce that, so there we go. Now we know what the reciprocal of secant is, which is cosine. 3 square root of 13 over 3. Now, let's see, there's different ways to do this. I'm going to go with tangent of x equals sine over cosine. That's how I'm going to do it. And so for tangent of x, I'm going to put 2/3. For sine of x, that's my unknown. I'm just going to call that x, I guess. And then cosine of x is 3 square root of 13 over 3. Now for me, anytime I have 2 fractions equal like this, I'm going to cross multiply. It makes it a lot easier. So 3 times x would be 3x. And 2 over 1 times this fraction here would be 6 square root of 13 over 3. Now divide by 3, divide by 3. Of course, dividing by 3 over here is the same thing as multiplying by 1/3, okay? And so your 3 would cancel, give you a 2. 2 square root of 13 times 1 is 2 square root of 13, and 3 times 1 is 3. And that looks like the letter B, but it's not. Slide it over a little bit. There we go. And there's your answer. So here we go. Now, understand here, students, if sine is to square root of 13 over 3, then we're going to flip it to get the cosecant. If you flip this, you get 3 over 2 square root of 13. So we're going to multiply the top and the bottom by square root of 13, square root of 13. Now here's what we get. We get 3 square root of 13, and then 2 times 13. Here's why. There's a 1 right here, okay? 2 times 1, outside number times outside number is 2. Square root of 13 times square root of 13 is 13. So you really end up with 3 square root of 13 over 26, okay? 3 square root of 13 over 26. That's for the cosecant. Now, I'm not getting that on my answer sheet, so I wonder what I did wrong here. Let me see real quick what I did wrong. Let's see. Maybe my answer sheet is incorrect. Let's see here. Okay, students, sorry about that. I'm back. I made a mistake way back here when I found cosine right here, and I apologize. Y'all probably saw it. And so my mistake is when you flip 3 over square root of 13, you get 3 square root of 13 over 13. Okay, so this would be a 13, okay? So when I came down here to my formula for cosine right here, I should have put this, a 13, and then when I flipped this, let's see, divide by 3, this would be 6, it'd be a 13 here. You end up getting 2 square root of 13 over 13. That's what you would get for sine, I believe. Let's see here real quick. Yes, that's correct. 2 square root of 13 over cosine. Let's see, it'd be 2 times 1. Let's see here real quick. Square root of 13, 3 times x over 13 divided by 3 divided by 3. That would give you 2 square root of 13. And that's for cosecant. And I believe that's correct. I hope that it is. Guys, I hope I'm not making a mistake. If I am, I'm sorry. If I could be there in class, y'all could say, you know, hey, Mr. Harrod, here's where you're messing up or whatever. I'm pretty sure that looks correct. Okay, I hope it is. Let's move on. Number 9. Okay, number 9 was very interesting. I need you to watch this carefully, okay? Y equals arc cosine of x over 4. Now, the first thing you do is you write cosine of y equals x over 4. Okay, then you make a table of values. And some of you did not use the proper angles for y, okay? I don't know why, but you forgot that cosine goes from 0 all the way to 180. It's very important. You get a big picture of this graph. Okay, so for y, you're going to put in 0, and then 45, then 90, then 135, and then 180. Now that's not the exact way you have to do it, but it's a very good way to do it, okay? Now if you put 0 in for y and solved, you would get 4. If you put 45 in for y and solved, you get 2.8. If you put 90 in for y and solved, you would get 0. If you put 135 in for y and solved, you get negative 2.8. If you put 180 in and solved, you get negative 4. Now, so some of you need to check your work here. One person used like 1, 2, and 3 for their y's, and I'm not sure where that came from, but y is your angle, and we're dealing with arc cosine, so whenever we put angles in for y, it's got to be between 0 and 180, okay? But anyways, moving on. So now, most of you got this part right, but your graphs were not acceptable, guys. I'm gonna really be tough on you on this, okay? And I taught you guys this. Your graph is supposed to have a little bit of a curve to it, okay? And we talked about this. Even if it looks like a straight line, okay? Okay, we're going to go up to 0, 45, let's see. Okay, so at 4, at 4 we're 0. 2.8 we're at 45. 0, we're at 90. Negative 2.8, we're at 135, so up here. And then at negative 4, we're up to 180 right here. Now, a lot of you just drew a line, and I've told you guys there has to be a curve to it, guys. There has to be a curve. Comes down, hits here, comes here, and then has a little curve right here. Okay, I'm going to show you why right now. Okay, watch this, please. Here's your standard cosine graph. Okay, we learned this a long time ago. Your cosine graph goes as high as 1, and then at 45 it hits here, and then at 90 it hits here, at negative 1. And let's see, 0. No, I see 91, 80. No, at 90 degrees it hits here, and 180 it hits here. So the graph looks like this. Remember this? This is the good old cosine graph we learned a long time ago, okay? Now, if you'll think about it, I went over all this in the video. I can show you the video if I had to, okay? We did this. What I said is, okay, dealing with arc cosine, we're going to cut the graph off from here to here. That's from 0 to 180, okay? Here's what we're going to do. Now watch. And what we said was this. We're going to take this graph, I shouldn't have done that. That's not a good idea. Hold on one second. Now here's what we're going to do. We're going to take this graph and we're going to flip it like this, okay? And we're going to rotate it so that it's looking something like this or something like this. Okay, now I know over here it's been flipped and all that, but don't forget we had a different, it wasn't a perfect arc cosine function like x over 4 and all of that. But the point is we went over this in the video, it's still going to have a bend or a curve to it, okay? It still is. And all of your arc sine or arc cotangents or arc tangents will, because we're just taking off a piece of it, and that's all the part that we're graphing, okay? So there is supposed to be a bend to it, okay? I hope that makes sense. All right, moving on. Okay, we're going to simplify this very quickly. It's very simple to do. First of all, I'm going to factor out a tangent squared. And when I do that, I'm left with cosecant x, cosecant squared x minus 1. And then if you'll look in your Pythagorean identities, cosecant squared x minus 1 is the same thing as cotangent squared x, okay? And then tangent squared is the same thing as 1 over cotangent, okay, times cotangent squared over 1, and there we go, those cancel, and you're left with 1, okay, which equals this. All right, okay, number 11. Okay, the ship is moving let's see here, 45 miles east. So here's the port, 45 miles east and 30 miles south, and it's right here. Okay, so this is 45 and this is 30. Now if the captain wants to sail directly to port, so here's the captain right here, and he wants to sail to port, which is over here, what bearing should I take? So here we go. Now, whenever you're looking for a bearing, remember the first thing you do is you start here and you say to yourself, am I going north or south? Well, I'm going north. To get from here to here, I know I'm not going to go due north, but I have to still go north somewhat. Okay, so am I going to go north or south? North. Okay, after you've established that, north blank something, am I going to go east or west? Well, I've got to go west, so it's north blank west. And you always draw your angle with the north or the south line that you've drawn. So here's the point, here's the north line I've drawn. So the angle then rotates this way to the west. This is the angle I'm looking for, and I have a right triangle. So there it is. That's simple, guys. So based on this angle here, I have opposite and adjacent. So tangent of theta equals opposite over adjacent. Use your second tangent button because you're looking for an angle. So second tangent of 45 divided by 30. And hit enter, and you should get approximately 56 degrees. So there you go. North, 56 degrees west. Okay? All right, number 12. Okay, a passenger in an airplane is at an altitude of 10 kilometers. Here's the ground. Let's see. Here's a city. Here's a city. Here's the airplane. Okay, he's 10 kilometers off the ground, so we'll call that 10. We don't care if our drawing is drawn to scale or not a big deal. In fact, I would prefer that your drawing is not drawn to scale if it makes your angles big enough to actually see and work with, okay, to be honest with you. So there we go. Now, let's see, the angles of depression are 28 and 55. Now remember, an angle of depression, please don't forget this, students. Angles of depression are always formed with a horizontal line, and depression means you're up in the air going downward, okay? So there's my horizontal line. So one angle goes from the horizontal to here, and the other angle goes from the horizontal to here. Well, here's my two angles. Obviously, the smaller angle is going to be 28 degrees, and the larger angle is going to be 55. So I'm going to put 28 degrees here. And then think about it, guys, if this whole angle here is 55, which it is, I'm just going to go ahead and put 27 degrees here because 28 from here to here plus 27 more is 55 degrees, okay? Now remember, the whole angle from here to here is 90, okay? It's 90. So if from here to here is 55, then over here I know this is 35, okay? Now, how far apart are the two towns? Well, look, guys, here's all you have to do. Here's one right triangle right here. Okay, watch. Here's one right triangle right here. See it? There it is. Got it? Okay, so I'm going to put that over here. Right angle, 35 degrees, height of 10. Here's another right angle. Starts here, goes all the way over, comes up to here, hits here. Okay, so I'm going to put that triangle over here. See this point right here, that point is about right here on this triangle over here. Here's the other point here. Right angle, and this would be, now here's your angle, here's your triangle right here. Okay, so 35 plus 27, this whole angle here is 35 plus 27, and that's going to be, let's see, 2 carrier 1, 62 degrees, I believe. 62 degrees. There we go. Okay, now, height of 10. Now, here's what I'm trying to find, is this distance right here. Well, students, if I can find this whole distance all the way across, which is this right here, and then find this distance here, which is this here, and then subtract the two, what I'm left over with is this distance here. So that's what I'm going to do, okay? So using trig functions, like over here I would use, we'll call this x, and we'll call this y over here. So we're going to say the tangent of 35 equals x over 10. Multiply both sides by 10. If you go ahead and solve that, you're going to get approximately 7, okay? 10 tangent of 35 equals x, you would get approximately 7. So from here to here is 7. Okay, now over here, if I said the tangent of 62 equals opposite over adjacent, multiply both sides by 10, I get this. Now, if you type that in your calculator, you'll get approximately 18.8. So from here all the way to here is 18.8. So the whole distance from here all the way across is 18.8. The distance from here to here is 7. Subtract those two and you get your answer, which is 11.8. 11.8. Okay, there we go. Okay, moving on to number 13. Here we go. Two fire towers are 30 kilometers apart. A is due west of B. So here's A. And here's B. Again, we don't care if our drawing is drawn to scale. That's not a big deal. So there we go. And the distance is 30. A fire is spotted due north of B. So go straight up. Due north of B. And the bearing from tower A to the fire is north 14 east. Now, a lot of you put the 14 degrees inside the triangle, and let me show you why you're wrong. Okay, watch this carefully. Look at the bearing. The bearing from A to the fire is north. So the first thing you do is you draw a line going north, okay? So there's your line going north. You did that because it says north. Then it says east, so you rotate 14 degrees east. And even though this is your triangle right here, the 14 degrees goes right here. And in your notes, guys, that's how I've taught you to do that. You go north and then 14 degrees east. Okay, so this being a right angle right here, then the angle inside the triangle that you'd want to use would be 76 degrees. And now the question is, find the distance from tower A to the fire. Here's your fire up here, okay? So we have this side here is my unknown. We have adjacent and we have hypotenuse. So the cosine of 76 equals adjacent over hypotenuse. Multiply both sides by x. And then divide by cosine of 76. And if you type this into your calculator correctly, you will get approximately 124, approximately. And so that is the distance here from A to the fire, or x, okay? 124. All right? Okay, one more problem and we're finally done. Here we go. This was a tough one here, guys, pretty tough. Okay, we're going to get a common denominator first of all, so I'm going to multiply the top times this denominator over here. So I'm going to have cosine x minus cosine y times this over here, which is cosine x plus cosine y, okay, all over my common denominator, which is sine x plus sine y. Cosine x plus cosine y plus, okay, over here I'm going to multiply the top and the bottom of this fraction by this right here, okay? So I'm left with sine x minus sine y times sine x plus sine y, okay? All over my common denominator. Which is right here, okay? Now, next, if I go ahead and simplify this real quick, I would get cosine squared minus x minus cosine squared y, okay, for this. And if I were to simplify this over here, I would get sine squared x minus sine squared y, okay? So now I have this plus this all over my common denominator, okay? So here we go. Here's my common denominator, bring it down. we go. Okay, now the first thing I see is the students. What I see is, let me erase this up here. A lot of you got half credit. It was worth 4 steps, so it was worth about, how many points did I take off? Every mistake on the test was 2.4 points off. So this problem here was worth about, let's see, about 9.6 points. Okay, and a lot of you got half credit for it. But listen, next, you need to move some terms around like this. Watch carefully. I'm going to put my sine squared first, and then my positive cosine squared next. Okay, and minus sine squared y minus cosine squared y. Now watch. Next, well, sine squared plus cosine squared is 1, so I have 1 minus, to factor out a -1, okay? And you're left with sine squared plus cosine squared. And of course, sine squared plus cosine squared, this whole thing just equals 1. So now you have 1 minus 1 times 1, which is 1 minus 1, which means your entire numerator up here becomes 0. Okay, so really it doesn't matter what your denominator was, because your numerator became 0. So I'm gonna put CD for common denominator. Okay, but as soon as your numerator becomes 0, then your whole fraction became 0. So, and that's what you wanted it to equal. If you look back up here, you wanted to prove that this whole side equals 0. Okay, as in terms of checking my work, when I took points off, if anywhere I marked the problem wrong and I put -1 PT, that means you lost 1 point. If I just put -1 or -2 or -3, that stands for a mistake, and each mistake was 2.4 points off. So you want to add all those up, multiply it by 2.4, and then subtract from 100. Okay, overall y'all did pretty well. I think there was 100. That was Michael. He deserves to be recognized for that. And then there was 193. That was Anna, I believe. Then there were a couple B's, maybe a C or two, and that was it. So, okay, guys. All right. That's it. I hope you guys have a good day. I hope this has helped you with your test corrections. Make sure you do them, turn them in, and I will talk to you guys tomorrow.